We'll proceed in vector algebra and calculus. Vector algebra and calculus. So this is the topic in which we are pursuing the discussion. So vector is considered as the most advanced kind of entity in mathematics. Vector, you are amazing, you are great. Now, in the vector algebra and calculus, we are in a phase, we are in a phase to calculate the surface area of a sphere, surface area of a 3D. Okay, so surface area of a 3D that we need to calculate through vector. So that is the concept, and we have seen primitive calculus, we have seen modern calculus, and then we have seen velocity acceleration vector. Velocity vector, surface area vector, velocity surface area, velocity magnitude, many things. So through velocity, primarily through velocity vector, we calculated the curve length. Through velocity vector, we calculated the surface area. Now through velocity vector, if we see calculating the surface area, okay, okay, I have a big sphere. Okay, so this is a sphere, a big sphere, and how we calculated the surface area of this sphere. This sphere is centered at the origin. So center of this sphere, it is matching the origin of the Cartesian coordinate system, that is x, y and z. X, y and z Cartesian coordinate system, this is centered at that point. If that is the case, if it is centered at that point and that is the case, from center there is a point here P. From center, if I connect this point P from center, if I connect this point P, then it is a position vector. If I have a position vector, then coordinate of P is x comma y comma z. So then the position vector is xi plus yj plus zk. If I do, now if I derive it, how you, you will derive it? There are two independent components here. If you see closely, then two there are two independent components. One is x-axis, one is y-axis. These two are independent components. This is dependent component, that is z-axis. This is xy plane. This is xy plane and this is z. What is z? Z is dependent upon xy plane. Simply I can say like that. Z is dependent upon x-axis, z is dependent upon y-axis, x is independent to y-axis, not required. Z is dependent upon xy plane. Now it is implicit that xy plane is formed because of x-axis and y-axis. If we connect these two vectors, the surface it is making, that is called xy plane. Z is dependent upon xy plane. If that is the case, then if I have a position vector xi plus yj plus zk, then derivative of the position vector, derivative of position vector with what? Okay, derivative of this position vector, derivative of this position vector with x-axis, this is called partial derivative, dp by dx. Derivation of this position vector with y-axis, dp by dy. If we talk about dp by dx, then if this is position vector, then this is point P, then I cut it in xz plane. I cut it in yz plane. Both will make a separate circle. This is what we saw. In xz plane, this is the circle. This is hop. Okay. Xz plane, this is point P. And in yz plane, this is point P. Okay, now this P is in yz plane here, and then this is xz plane. Now here, if I say, if I cut it into a kind of vertices, two planes, if that is the case, then at point P, if I calculate dP by dx, what it will? This is what we have already talked about it. So dP by dx is I plus dz by dxk. dP by dy is j plus dz by dxk. dP by dx is an array, is a vector. dP by dx is a vector which has I component fixed one and k component, that is dz by dx. dz by dx would be dependent upon x and y. If z equal to square root of a square minus x square minus y square, that is the formula of a sphere, then dz by dx is minus x by square root of a square minus x square minus y square. dz by dy is minus y by square root of a square minus x square minus y square. If these are the case, then dz by dx is a function over x and y. dz by dy is function over x and y. So if I say dp by dx, d position vector by dx, then it is I, that is fixed x1 plus dz by dx. K component is dependent upon x and y, wherein dz by dy j plus dz by dy k. So this proves that if if this is position vector p, if I cut it like this, then dp by dx is at this moment it is tangent at this point, and this tangent is in xz plane. dp by dy is tangent at this point, and that tangent is in yz plane. If I make cross of these two vectors, this vector and this vector, it gives me momentarily surface area at that point. Okay, I believe it's alright. But the concept of the velocity vector is dp by dx. If p is the position vector, then dp by dx is velocity vector. If p is position vector, then dp by dy is velocity vector. Certainly, right? If I have displacement and if I do the first derivative, it will result into velocity. If I do again a differentiation, it will result into acceleration. If I do integration of acceleration, it will result into velocity, and then velocity into displacement. This is the fundamental of the calculus. So if I have dp by dx, it is called velocity vector, that is in xz plane. dp by dy is velocity vector, that is in yz plane. If I make cross of this, then it will result into surface velocity vector. Surface velocity vector, where dp by dx in xz plane, tangent at this point, dp by dy is in yz plane, tangent at this point. So at this point, there is two tangents. At this point, two tangents are formed. Okay. Okay, at this point, two tangents are formed. One tangent is in xz plane and one tangent is in yz plane. So if I show it, show it like this, then it is like this. So that is the velocity surface area at that point. What about top? Top, this is xz plane and this is yz plane. They are perpendicular to each other. I am taking too many things. Okay, on the top, it is like this. They are perpendicular to each other. Okay, I believe they will be perpendicular to each other in the sense that plane is perpendicular to each other. This is top one. So wherever you go, they will change in the direction as per the dz by dx and dz by dy. K factor is concerned. So if I have dp by dx cross dp by dy, it resolved in the velocity surface area vector, because cross product would go with the surface. So velocity surface area. If I calculate the magnitude of the velocity surface area, it is velocity surface. If I integrate it, it will give the displacement, the surface area. If I have velocity vector, if I calculate the magnitude, it results in velocity magnitude. If I integrate, it gives me displacement. If I have velocity surface vector, if I calculate magnitude and then integrate it along the xy plane, because here x is involved, y is involved. Along the xy plane, then it resolves in like in getting the surface. Velocity surface vector. Calculate the magnitude, integrate with the xy plane. It will give the net surface as per the normal calculus fundamental. I'm not going to delta and here and it. Just leave everything and just talk about the normal calculus. Velocity surface vector, anyone would say. If I integrate velocity surface vector, then I'll surface vector, okay, then I would get the kind of a position vector. Something cryptic. Someone can try it. I have never tried. But if you calculate the magnitude of the velocity surface vector and then integrate with dxy plane, it will give you the magnitude of the surface. Okay, that is the concept. Okay, I have also demonstrated that if I have a velocity vector, if I have a position vector, if I differentiate it, it becomes velocity vector. If I integrate it, it becomes this position vector again. If I have position vector and if I differentiate it, it becomes velocity vector. If I calculate magnitude of the velocity vector and integrate, it gives the magnitude of the displacement. That is nothing but the curve length. Now someone would say, this also I am repeating. Then someone would say, when you are calculating the magnitude of velocity vector and then you are calculating the integration, why you are not calculating the magnitude of position vector itself? I have demonstrated vector is not the only magnitude. Vector has direction also. So if I say if I take two-dimensional case, I'm trying to find the curve length. If that is the case, this is position vector. If this is position vector, if this is position vector, then if I calculate the magnitude of it, it will resolve into radius of this circle. Magnitude of this position vector is radius of this circle. This is what we don't want. We want this length, not the radius length. In that case, we need the curve vector. If I get curve vector and if I calculate the magnitude of it, it will resolve into the length of the curve because curve vector is along the arc. I have also discussed that if I have a vector and if I calculate the magnitude, if I have a line, simply a line, if I get the vector formula of this line and calculate the magnitude, it will give the length of the line. Like if I have a curve and if I find the vector formula of this curve and calculate the magnitude, it will give the length of the curve because vector magnitude is the length of the vector. But vector is varying. That is the problem. Vector is not constant. In that sense, we calculate the magnitude and integrate. That is disputable, but here it is straightforward. If I have a position vector, if I calculate the differentiate, it becomes velocity vector. And fortunately, velocity vector is along the curve only. But if I calculate the magnitude of the velocity vector, it is the velocity magnitude. Now you have to integrate it to get the actual curve length because velocity vector will not get the curve length. Integrating it, it will resolve into displacement. Same thing is with the surface area also. If I have velocity vector in xz plane, velocity vector in yz plane, if I make cross, it give a velocity surface vector. Calculate the magnitude and then integrate with the xy plane, it will give the surface area. Anyway, that is over. Now, next thing what we saw here is that we tried into spherical coordinate system. So what is dp by dx cross dp by dy? Now instead of dp by dx cross dp by dy, can I try in polar coordinate system? So polar coordinate system dp by dx. So dp by dx cross dp by dy is nothing but the surface area by dxy plane. Integration with dxy plane. This is what we are trying. So now I am going to multiply it by d theta phi by d theta phi. Because in polar coordinate system, if I try to find the surface area of this, then radius is constant. If I try to find surface area of this, then at full surface radius is constant. Theta is varying and phi is varying. I have demonstrated theta and phi in the past video. So phi is the angle radius makes with the vertical and theta is the angle that radius makes in the xy plane. That is theta. And with a vertical with z axis, whatever the radius is making the angle, that is called phi. So phi goes from 0 to pi, whereas theta is radius, it makes on the xy plane. One with the z axis and one is along the xy plane. This is called theta. So theta goes to pi and phi goes 0 to pi. Here phi would vary and theta would vary. Radius is constant at the sphere surface. So we want variable here. Xy is the variable when I say dp by dx cross dp by dy. If I go in spherical coordinate system, then phi and theta, they are variable. Radius is constant. A. In that case, now I can say dp by d surface area by dxy plane into dxy plane is equal to whatever we have d surface area by dxy plane into dxy plane into d theta phi by d theta phi. Now dx by dxy I can cut down and d theta phi all are new. These are not available in any of the book, whatever we are saying. So d surface area by d theta r magnitude into d theta r. So d surface area by d theta r, if d surface area by d xy plane is dp by dx cross dp by dy, then d surface area by d theta r dp by d theta cross dp by dr. Okay, I can prove that also, but I believe in one of the video we have proved it, innovative calculus or something like that. So dp by d theta cross dp by dr into d theta dr, it gives the surface area we have seen. Now position vector p is in xi plus yj plus zk. Now transformation of the Cartesian to the spherical coordinate system is r is a is the sphere radius a sine phi cos theta I plus a sine phi sine theta j plus a cos phi k. This is position vector by d theta cross a sine phi cos theta I plus a sine phi sine theta j plus a cos phi k by d phi. Calculate this cross product, take the magnitude of this and then d theta d phi. We have done it and it comes at 4 pi a square, that is the surface area. Now what is the discussion? Again, what I am going to talk now, it is again not available in any of the book. Please do support us. +91 is the India country code 94831606110. Okay, now can we do this computation in a spherical coordinate system only? If you see closely, then I have transformed dp by dx cross dp by dy magnitude and then integration with dxy plane or dx dy into dp by d theta cross dp by d phi magnitude d theta d phi, where p position vector that was xi plus yj plus zk now transform into a sine phi cos theta I plus a sine phi sine theta j plus a cos phi k. If that is the case, now this is something that is hybrid model. We have position vector still in xyz coordinate only. Just I change it into the xyz coordinate is dp by dx. Position vector is is a sine phi cos theta I plus a sine phi sine theta j plus a cos phi k. I, j, k is still there and theta phi is a spherical coordinate system and position vector is still in I, j, k Cartesian coordinate system. Can I calculate surface area in a spherical coordinate system? That is the question. Rather than, so if that is the question, then what is the actual vector in a spherical coordinate system? What are the independent variables? Theta, phi and radius. Theta in xy plane it goes 2 pi, phi in kind of xz or yz plane from vertical it go phi, depend upon the theta. If there is some theta then it will go like this. If theta is 0 then it will go like this. If theta is 90 degree then it will go like this. Okay, 0 to pi. What are the vectors in polar spherical? These are certainly not available anywhere. What are can someone think that what are the vectors? What are the vectors in spherical coordinate system theta, phi and r? What are these vectors? So if I have a sphere and it is centered at the origin, if I have a sphere and it is centered at the origin, If I have a sphere and it is centered at the origin, from origin, if I take any point P here, any point P here, I'm not talking about X, Y, Z, any point P here, from origin, if I take a line, that line is radius line. That is radius vector. Three vectors, right? One is theta, one is phi, and one is radius. What are the three vectors in spherical coordinates? I'm not talking about Cartesian X, Y, Z or I, J, K at all. So radius vector is from center, origin, center, any point P. If I draw a vector, that is the radius vector. What about theta vector? Theta is moving like this, right? Okay, what is theta vector? What is phi vector? That is a big question, right? Radius vector, someone understand straight line, that is a radius vector. What about this? How how polar coordinate system is a coordinate system? That is in question. How polar coordinate system is a coordinate system? That is a question. Polar coordinate, any coordinate system, its variables are independent to each other. If it is Cartesian coordinate system, then x-axis, y-axis perpendicular to the x-axis, z-axis perpendicular to the x-axis, perpendicular to the y. All should be perpendicular to each other. If there is a theta, the theta is the angle, right? Radius is like this. How they are perpendicular to each other? Then there is a phi, that is again angle. How this phi angle is perpendicular to the radius? But they should be perpendicular to each other as far as coordinate system is concerned. Then there is something called arc. If this is theta, let's consider this is theta. This is theta r plane. This is theta r plane. If this is radius, if there is angle theta, it is making, then knowingly, unknowingly, at point of radius, it is making an arc. Here, theta angle is 0, and this is radius a. If I move theta here, then it moves this much arc. So arc represents the angle theta. Now, if I take this radius vector and this arc, at any point, this arc vector is tangent to the arc. This arc vector and radius vector are perpendicular to each other. So arc vector represents the angle theta. So radius vector is a vector, like I vector represent x axis, j vector represent y axis, and k vector represent z axis. These are lines. X axis means y equal to 0 or z equal to 0. Y axis is x equal to 0 or z equal to 0. Z axis is y equal to 0 or x equal to 0. These are lines. Representation of this line is I vector, j vector, k vector. Like that, representation of radius is r vector. It's a straight line, r vector. Where representation of theta is if I draw an arc or arc, if I draw an arc with angle theta, then this this arc, every moment arc is the line that represent the theta independent variable. Radius vector represent the radius independent variable in spherical coordinate system. If angle is theta, then this line that like x-axis, y-axis, z-axis, this line represent the theta axis. Okay, if I talk in vector, then tangent at every moment is the theta axis. That is variable, right? It's not constant like I vector, j vector, k vector, whatever it is. So, what is this vector? What is this curve? That is a theta, a theta. If it is a and it is theta, a theta. So I can say a theta, a vector x, how we represent xi plus yj plus zk in Cartesian coordinate system. So if I start with theta, radius and phi, then theta is a, a, a theta vector, a theta, that is magnitude like xi, a theta, and then theta vector. plus radius is r vector. R vector. Makes sense? And then phi. Phi is now, if from vertical it is, then this is the arc it is making. If this is the arc it is making, then it is a phi. It is a phi. So now I can say that the coordinate system in a spherical, this is not available anywhere else. Why I am talking future of this is, now this will lead into surface area calculation. This is our proof. Okay, now it is a theta, theta on top of it vector sign, a theta, theta vector, plus plus a or r vector, plus plus a means full radius, a means full radius, or I can say more term r theta theta vector plus r vector, r theta theta on top of it vector sign, plus r vector sign, plus r phi r phi phi vector sign. This is the kind of 3D representation in vector notation for a spherical coordinate system. If that is true, then what is surface area? Okay, I believe we'll talk in next session because time is flowing. Now, if I take any point P, at this point P, now if I talk in the phi, then there is an arc in vertical direction. If I take theta, then there is a arc in horizontal direction. If I take a small area here, area means two sides, volume means three sides, and curve means one side. If I take a small area here, then it has two sides. One is the horizontal arc, one is the vertical arc. Now, if I vertical arc and horizontal arc, if I take in vector form and calculate the cross product, then I get the surface area directly. Okay, please you can take it as an assignment where the surface area vector I'm trying to calculate, and at any moment, okay, so two vector we are interested in. One is phi vector and one is theta vector. Theta vector is r theta theta vector. Phi vector is r phi vector. R phi vector. If that is true, then how we can calculate surface area with this fundamental? Not only that, then we will progress into dp by d theta cross dp by dr, magnitude d theta dr, but the p will be in theta r phi coordinate system, not in I j k coordinate system. This is very simple and big gain over the hybrid what we are taking. Just knowing the spherical coordinate system is sufficient. Idea was to finish it today. But anyway, this can be taken into assignment and someone can calculate the surface area. It's not difficult, right? Calculating a surface area, if I do cross product, I can calculate the surface area. If I do cross product, what is one? What is one? That is a one is radius theta. If I move delta theta, because area is very small, I have taken delta area, right? So for that, the arc in the theta is r r d theta vector, and in phi it is r d phi vector. If I do cross product of these two vectors, then theta vector and phi vector would resolve in the r vector, because cross of ij is k, then theta phi is r vector. What about these two cross product? What about these two cross product? R and there again r square, right? R square is the surface area. It's not like that. Okay, someone can try. Amazing, right? Just with the spherical coordinate system, we are trying to find the surface. We will see it. It's too long. I thought finish it. Okay, that we will see. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India. country code.